last lecture we have seen some points from unit number 1, and first point was statement. So we have seen statement is nothing but sentence for which it is possible to assign either true or false value. Okay. Again we have seen there are two different types of statements, that is atomic, primary, and second one is compound or molecular. So what is meaning of atomic statement? Have you remembered what is a atomic statement? What is a primary statement? Yes. Can anybody tell what is a atomic statement? Yes, are you there? Hello.
Yes, ma'am.
What is meaning of primary statement? So I will tell you once again. A statement without any sentential connective is called as primary or atomic statement. In that we have seen an example. Today is Sunday. In this there is no any connective symbol like and or. That's why this one is called as primary, atomic or primitive statement. Okay. Again we have seen second type of statement, that is compound or molecular statement. A statement which is formed using sentential connective is called as compound or molecular statement. In that we have seen one example. Today is Sunday and it is holiday. So here and this is a connective word, and that's why this is called as compound or molecular statement, because that word and is used to connect two different statements. First statement is today is Sunday and second one it is a holiday. So conjunction between these two statements is formed by and. That's why this one is called as compound or molecular statement. After that we had seen what are the different connectives. So there are five different connectives. First one is negation, then conjunction, then disjunction, conditional, and last one is a biconditional. So we have seen first one is conjunction. So what is meaning? Sorry, first one is negation. So what is meaning of this negation? Can you tell me one example that is representing negation? If you have understood, please answer. Otherwise, I will not get whether you are getting the things or not. Just you have to tell one example that is containing negation.
It is not case that today is holiday.
Okay, it is not the case that today is holiday. So here the phrase it is not the case that indicates this is a negation. Second option, we can construct a same negation using second option by placing not word at a proper place in a sentence. So this statement can be formed as it is not or today is not a holiday. So here when I used word not at a proper place. That's why there are two different ways to form a negation from given sentence. First one, we can use phrase that it is not the case that, and second one, we can use word not at proper place to form a negation of that given statement. Okay. So if there is one variable p and if that p is containing value t, then negation of p will have value p or f. Yes. If P is having truth value T, then negation of P will have truth value
False.
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 Okay. So this is for negation. After that, we have seen the next connective, and that one is the conjunction. So this conjunction, we can say that this is also a AND operation, and this conjunction is having truth value P when both P and Q are having truth value P. Then that's why its truth table is like here. When both P and Q are having truth values T, then only P conjunction Q will have truth value T. Otherwise, it is false. Next, we have seen next operation, that is disjunction. For this disjunction, it has truth value false if and only if both P and Q have their truth values false. Otherwise, it is true. That's why whenever P and Q both are having truth value false, then only the final value will be false. Otherwise, it is true. Then next, we are saying what is a conditional operator. So conditional, we can say that P conditional Q as if P then Q. So this is a conditional operator. Here, the truth value in the final column becomes false when P is having truth value P and Q is having truth value false. Then only final value is false. And for remaining combinations of truth values, it is T. So T, F, F. So this is for conditional. In that, we have seen one very important formula as P conditional Q is equals to negation P or Q. So whenever we have to convert this conditional, we have to take negation of first variable, then we have to give this or symbol, and then second variable as it is. So P conditional Q, this is equivalent to negation P or Q. Last operation, that is biconditional. So here this biconditional is also read as P if and only if Q. Okay. So for this biconditional, again we have seen this P biconditional Q will have truth value P whenever P and Q are having identical truth values. These were same truth values. Now check here, P and Q both are having truth values P. That's why final value is P. In the last value, last row, again both P and Q are having truth value false. That's why final value is P and remaining values are false. So here we can say that P biconditional Q is having truth value P when both P and Q have their identical truth values. Okay. So again, for this biconditional, there is one important formula P biconditional Q. This is equivalent with P conditional Q and Q conditional Q. So again, I am telling you this formula is very important. You have to take this in your mind because we are going to solve some examples based on these. Okay. So again, next point we are seeing is statement formula. And so from these variables we can form multiple statement formulas like negation P, P or Q, in bracket P and Q or negation P. All these are examples of statement formulas. So statement formulas nothing but any formula which is consist of variables, parentheses and connective symbols. Okay. And in the last lecture, we had just started with a well form formula. So now we have to see what is the well form formula, how to recognize it. Okay. So till now, have you understood all the things those we have seen? Do you have any difficulty? Hello? Hello?
Yes,
Have you understood all these things?
yes, ma'am.
Okay. Yes. So now we are going to see what is the concept of well-formed formula. So definition for well-formed formula: a statement formula is an expression which is string consists of variables, parentheses, and connective symbols. A recursive definition of statement formula is often called as well-formed formula. So in short, we can say that well-formed formula is a statement formula, and statement formula is a formula which is consists of variables, parentheses, and connective symbols. So statement formula is nothing but a well-formed formula. And here they have mentioned some rules how to identify whether any formula is well-formed formula or not. Okay, and those rules are: rule number 1, a statement variable standing alone is a well-formed formula. Means what? If there is any statement variable like A is a statement variable, so that is a well-formed formula. Okay. Now second one, if A is a well-formed formula, then negation of A is also a well-formed formula. Okay. So if there is any variable A, then if that A is well-formed formula, then negation of A is also a well-formed formula. Third one, if A and B, two variables are there, and if both the variables are well-formed formula, then A and B, A or B, A conditional B, A biconditional B, all these are well-formed formulas. Okay. And last one, a string of symbols containing the statement variable, parentheses, connectives is a well-formed formula if and only if it can be obtained by finite many applications of rules 1, 2, 3. Okay. In short, we can say that any formula which is constituted using rule 1, 2, 3 is a well-formed formula. So, here many times they have asked me question like write a short note on well-formed formula for 4 months or 6 months. In that you have to give definition of well-formed formula, rules for well-formed formula, and examples of well-formed formula. So here are some examples given. From that you will get clear idea about well-formed formula. First example, negation of P and Q. So here this negation is applied to this whole bracket. So this one is a well-formed formula. Why? Because it is containing parentheses, variables, and connective symbols. Okay, all are there. That's why this one is a well-formed formula. Now second one, negation of P or Q is again this one is a well-formed formula because again it is consists of parentheses, statement variables, and connective symbols. Third one, third one is also a well-formed formula. Again, fourth, fifth, all these are well-formed formulas because all of them are satisfying the conditions that they are containing variables, then parentheses, and connective symbols. That's why those are called as well-formed formulas. Now, here are some examples. Those are not a well-formed formula. Now, first example is negation of P and Q. So this is called as, this is not a well-formed formula. Why? Can you tell me why this one is not a well-formed formula? What we have seen, to form a well-formed formula, there must be a parenthesis, connective symbols, and statement variables. Now, this first example is not a well-formed formula because here is missing of parentheses. Parentheses are not given. So we can place this parenthesis as in parenthesis negation of P and Q or negation in bracket P and Q. In both the ways, we can form a well form formula. But this given formula is not containing parentheses. That's why it is not a well form formula. Have you understood what is the concept of well form formula?
Yes, ma'am.
Okay.
Yes, ma'am.
Good. Now, see the second example, and here you have to tell me why this one is not a well form formula. P conditional Q, conditional in bracket and Q. Now, for each and every term, you have to check whether this formula is containing parentheses, connectives, and statement variables. Look at the formula and check, tell me whether this one is a well form formula or not. Check whether appropriate parentheses are there in this formula.
Ma'am, variable is missing before and Q.
Is good. So here one variable is missing because this AND operator operates on both variables. So here one variable is missing. That's why this one is not a well form formula. Now, if you consider third example, what is missing here? In this third example, one parenthesis is missed here, closing parenthesis. That's why this is not a well formed formula. And if you consider fourth example, what is missing here?
Parenthesis.
Again, parenthesis is missing.
Parenthesis.
Yeah, that is opening parenthesis is missing. That's why this is also not a well formed formula. So this is the concept of well formed formula. Have you understood?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So now we will move to the next concept, that is tautology. So here definition is given for tautology: a statement formula which is true regardless of truth values of the statement which replace the variables in it is called universally valid formula or a tautology or a logical truth. Okay. So in short, we can say that a statement formula which is containing all values true in last column is called as tautology. All are true. That is called as tautology. Variables in it is called universally is called a contradiction, and here we can say that the negation of contradiction is a tautology. So if you apply negation to tautology, it will give you answer as contradiction, or if you apply negation to contradiction, it will give you answer as tautology. So in short, we can say that if last column, then that is second. If last column of your statement formula is containing all values false, then that is called as contradiction. And negation of contradiction is a tautology, and negation of tautology is a contradiction. Now here, take this truth table and tell me what is this, either contradiction or tautology. Check for the last column. Here, this last column is containing all values false. That's why this one is called a contradiction. If you consider the second last column, here this column is containing all values as true. That's why we can say that for this column, this is a tautology. So this is the concept for tautology and contradiction. Now here we have to solve some examples based on this tautology and contradiction. So here question is asked as, from the formulas given below, select those which are well-formed formulas, that is called as WFF, and indicate which ones are tautologies or contradictions. Okay. So first example is given. So first of all, we have to recognize whether this formula is well-formed formula or not. Now check, is this well-formed formula?
Yes, ma'am.
Yes,
Yes.
because this
Yes,
is,
ma'am.
Yes.
yeah. Okay. So here this is containing parentheses, then statement variables and connective symbols. That's why this one is called as well-formed formula. Now we have to find out whether this one is tautology or contradiction or neither tautology nor contradiction. So this example, take 2 minutes and tell me whether this one is tautology or contradiction.
Tautology. Tautology, ma'am.
Tautology.
Okay, we will check.
Tautology.
Yes, because last column of this truth table is containing all values true. That's why this given formula is tautology. Correct. Now second one. First of all, we have to check whether this one is a well-formed formula. Tell me whether this formula is a well-formed formula. Why it is taking this much time? Just you have to check for whether it is containing appropriate number of brackets, that is parentheses, whether it is containing required number of variables and connective symbols. If all are there, then we can say that this given formula is a well-formed formula. Yes, what happened?
Tautology.
I am asking about whether this one is a well-formed formula. Then we will check whether this one is tautology or contradiction. First of all, tell me whether this one is well-formed formula or not. Yes, whether this one is a well-formed formula.
No,
Yes,
ma'am.
ma'am.
Okay.
Yes, ma'am.
Now we have to check whether this one is a tautology or contradiction. Again, its last column is containing all truth values as P. That's why this one is a tautology. Now third one. So again we have to check whether this one is well-formed formula, and then we are going to check whether this one is a tautology or contradiction. So whether this one is well-formed formula?
Yes.
Yes.
Yes, ma'am.
Yes, ma'am.
Now check for whether this one is a tautology or contradiction.
Contradiction, ma'am.
Contradiction.
Contradiction, ma'am.
Contradiction.
Yes, we will check. Yes. Last column is containing all values false. That's why this one is a contradiction. Next one. Whether this one is well-formed formula?
Yes.
Yes.
Yes, well-formed
Yes, ma'am.
formula. Correct. Now check for tautology or contradiction. Have you solved? Yes. So this is containing put values as T, F, E, T. So we can say this is neither tautology nor contradiction. Okay. So I hope you have understood the concept of tautology and contradiction. Now we will see the next point as substitution instance. So, definition is given as a formula A is called as substitution instance of another formula B if A can be obtained from B by substituting formulas for same variable of B with condition that same formula is substituted for same variable each time it occurs. Means what? If A is derived from B, then A is called as substitution instance of B with the condition that same formula is substituted for same variable each time it occurs. Okay. I know that this definition is quite lengthy, but if you look at the examples, you will get idea. So here formula B is given and this is containing variables. So P conditional J and P. Okay. So here we have decided to substitute R biconditional S for P. So for this variable P in B, we have to substitute this formula. So again, we have to check how many times P has occurred in this formula. So twice B as R biconditional S conditional J and R biconditional S. So here we have obtained A from B. That's why A is called as substitution instance of B. So again, so this is meaning of this statement with the condition that same formula is substituted for same variable each time it occurs. जे जितक्या वेळा ते व्हेरिएबल आलं असेल तुमच्या फॉर्म्युलामध्ये तेवढ्या वेळा ते व्हेरिएबल त्या फॉर्म्युलाने रिप्लेस करायचे. सो हियर वी हॅव डिसाइडेड टू रिप्लेस दिस व्हेरिएबल p by formula r by conditional s. So whenever that p has come, we have to replace it by r by conditional s. So this A is called as substitution instance of B. Have you understood?
Yes, ma'am.
Okay.
मॅम अजून एकदा एक्सप्लेन करा.
अजून एकदा सांगा. Okay. So here definition of substitution instance is a formula A is called as substitution instance of another formula B. If A can be obtained from B by substituting formulas for some variables of B with the condition that same formula is substituted for same variable each time it occurs. Means what? Suppose there is one formula B and we are going to derive another formula A from B. Then there is one condition, we have to replace same variable of B with the same formula each time it occurs. Then A is called as substitution instance of B as A is derived from B. Now here consider example statement formula, that is B is given. That formula is P conditional J and P. So here we have decided to replace this P with the formula R by conditional S. So again there is one condition that we have seen here. Same formula is substituted for same variable each time it occurs. म्हणजे ते व्हेरिएबल तुमच्या फॉर्म्युलामध्ये जितक्या वेळा आलंय तितक्या वेळा ते व्हेरिएबल सेम फॉर्म्युलाने रिप्लेस करायचे. आता इथे आपण काय म्हटलं आर बाय कंडिशनल एस. दिस इज द सबस्टिट्यूशन फॉर व्हेरिएबल पी. आता पी दोन वेळा आले तुमच्या फॉर्म्युलामध्ये, सो आर बाय कंडिशनल एस मस्ट बी देअर ट्वाइस. So replace this P by R by conditional S, then conditional J, and again P has come. So again this variable P must be replaced by same formula, that is R by conditional S. So here A is called as substitution instance of B because we have derived this A by replacing some variables of B by using condition same variable must be replaced by same formula each time it occurs. Are you getting?
मॅम
Yes, ma'am.
एक्सप्लेन करा. तुमचा आवाज ब्रेक होत होता.
ब्रेक होता है. हेलो
ना एक्झाम्पल एक्सप्लेन करायच्या टायमाला तुमचा आवाज ब्रेक होत होता.
ओके, परत एकदा सांगू का एक्झाम्पल? ओके,
हाँ मैम.
यस मॅम.
कन्सेप्ट समजली का काय आहे सबस्टिट्यूशन इन्स्टन्स म्हणजे? एका फॉर्म्युल्यावरून आपण
Yes, ma'am.
डेरिव्ह करणार आहे. ओके
हा मॅम, बस एकदा एक्झाम्पल एक्सप्लेन करा बस.
ओके, नो प्रॉब्लेम. So here one formula is given, that formula is B and that is P conditional J and P. Okay, so here they have given substitution for this P as R by conditional S. Okay, now we have to form substitution instance of B. Okay, and that substitution instance we have considered here as A. So Whenever P is there in this formula, we have to replace that P by formula R by conditional S. Okay. So replace this P by R by conditional S, then conditional as it is, J as it is, and as it is. Again there is second occurrence of P. So again for this P, we have to use same formula as R by conditional S. So this whole formula, that is A, is called as substitution instance of B. तुम्हाला काय करायचं आहे, फक्त त्या व्हेरिएबल साठी जो कुठला फॉर्म्युला सबस्टिट्यूट करायला दिलाय तो फक्त तिथे पुट अप करायचा. जो फॉर्म्युला तयार होईल दॅट इज कॉल्ड एज सबस्टिट्यूशन इन्स्टन्स ऑफ ओरिजिनल फॉर्म्युला. समजलं काय केलंय?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Good. Now check. Here R by conditional S, conditional J and P. This is not a substitution instance of B. Why? Because we have written here condition that same formula is substituted for same variable each time it occurs. Now here in this formula P is occurred twice, but in this formula P is replaced by given formula once, but for second time we have kept this P as it is. That's why this one is not a substitution of B, a substitution instance of B. प्रत्येक वेळी जेव्हा तो व्हेरिएबल येईल तर त्या सेम व्हेरिएबल साठी सेम फॉर्म्युला आपल्याला पुट करायचे. Then only we can say that new formula is their substitution instance of given formula. Okay, now here one example is given. Substitution instances of P conditional negation Q are: first is R and negation S, conditional negation of J or M. So here we have to tell me which formula is used for which variable as a substitute. Consider first formula and tell me which one is substitution for P and which one is substitution for Q.
For P, R and negation of S.
Is correct. And for Q?
For J or M.
J or M. Good. Now, if you consider second formula, in this formula, P is replaced by R and negation S, and Q is replaced by R and negation M. For third one, P is replaced by R and negation S, and Q is replaced by P. And for last one, P is replaced by Q, and Q is replaced by P and negation Q. So these are the substitution instances of given formula. So have you understood what is the concept of substitution instance?
Yes, ma'am.
Okay. So here one question is given. Produce the substitution instances of following formulas for given substitution. So here they have said one formula is given and that formula is P conditional Q, conditional P, conditional P. And here they said that substitute P conditional Q for P and P and Q conditional R for Q. Now we have to substitute these given formulas in the given statement and you have to tell me what is the substitution instance. Thus you have to put these given formulas in a proper place. In a proper place, like whether that formula is for P or for Q. Now here in this formula, P has occurred thrice, 1, 2 and 3. So this P should be replaced by same formula as P conditional Q. And Q is occurred only once, that's why this Q should be replaced by P and Q conditional R. Then you will get substitution instance. Can you solve this?
Yes, ma'am.
Yes, ma'am.
So this is your answer. Check whether you have got same answer. P conditional Q. This is for P. Okay, again conditional P and Q conditional R. This is substitution for Q. Conditional P conditional Q. This is substitution for P. Again conditional P conditional Q. Again this one is substitution for P. Have you got same answer?
Yes, ma'am.
Okay. Now here in this formula you have to substitute Q for P and negation P for Q. Now solve this and you have to tell me this answer. Substitution for P is Q and substitution for Q is P and negation P. Whenever P is there, you have to replace that P by Q and Q by P and negation P. Orally, you can solve this example. Why you are taking this much time? Unmute your mic and tell me what is your answer. Is have you solved?
Yes, ma'am.
What is your answer?
Yes, ma'am.
Q conditional
Okay, Q conditional,
P and negation P.
P and negation P.
Conditional P and negation P. Conditional Q.
Okay, good, correct. So this is the concept of substitution instance. So now we will see the next point. equivalence of formulas. Okay. So this is also very important point. Many examples are asked based on this. Let A and B be two statement formulas and let P1, P2 up to Pn denote all the variables occurring in both P and Q. Consider an assignment of truth values to P1, P2 up to Pn and resulting truth values of A and B. So this is just introductory part. It is not required to write. If the truth value of A is equals to truth value of B for every one of the 2 raised to n possible set of truth values assigned to P1, P2 up to Pn, then A and B are said to be equivalent. So this statement is very, very important. How to check equivalence of formulas? So what they have given, if truth values of A and B are same for every one of the possible combinations from 2 raised to n, then we can say that A is equivalent to B. Okay, and there is another way to take this equivalence as the final columns in the truth tables of A and B are identical, then only we can say that A and B are equivalent to each other. Okay, so here we have to check for final columns of A and B. If both A and B are containing same values in final column, then we can say that those two formulas are equivalent to each other. Okay. So here examples are given. Negation of negation P is equivalent to P. How? Because this negation get cancelled, so you will get answer as P. Okay. P or P. This is equivalent to P. P and negation P. So or Q. So here value for P and negation P. This is false. So F or Q. It will give you answer as Q. P or negation P, this is equivalent to Q or negation Q because value for P or negation P is P and value for Q or negation Q is also T. So these two formulas are equivalent. Okay. So again this statement is given. This statement formulas A and B are equivalent provided A biconditional B is tautology. Okay. So here one very important statement is given. A and B are said to be equivalent if A biconditional B is tautology. So this is very, very important to check whether given formulas are equivalent or not. And we can say if A biconditional B is tautology, then A and B are equivalent. The meaning of both these statements is same. First statement, A and B are equivalent if A biconditional B is tautology. Second one, if A biconditional B is tautology, then we can say that A and B are equivalent. Meaning of these two statements is same. Then this equivalence between two formulas A and B is represented using A. This symbol is for equivalence. A equivalent to B and read as A is equivalent to B. So this is the symbol for equivalence. Again, this equivalence satisfies symmetric property. So now we have to see what is the symmetric property. If there are two different formulas A and B, and if A is equivalent to B, then B is equivalent to A. So this is called as symmetric property. If A is equivalent to B, then B is equivalent to A. Second property is transitive property. So if there are three different formulas and if A is equivalent to B and B is equivalent to C, then A is equivalent to C. So this is called as transitive property. So this equivalence satisfies two properties. First one is symmetric and second one is transitive. So this is the concept of equivalence. Now here we have to show that this formula is equivalent to this given formula. That is, P conditional Q is equivalent to negation P or Q. So how we can show this equivalence? So for that purpose, we have to draw a truth table. So again here only two variables are present as P and Q. So P, Q, again next column is for P conditional Q, then negation P, then negation P or Q. Then here we have to take by biconditional. Now check whether biconditional between these two is tautology. If that is tautology, then we can say that P conditional Q is equivalent to negation P or Q. Okay. So here we have to check for values for P conditional Q. So for this P conditional Q, Pf is F and the remaining values are P. Negation P means FFPP. Okay. Negation P or Q. When both the values are false, then only final value is false and remaining values are true. Now we have to take biconditional between P conditional Q and negation P or Q. So for this biconditional, if they are containing identical values, that is same values, then final value is P. Now check PT, same value, that's why final value is P. FF, same value, so P. Again PT, same value, so P. And PT, again P. Now check, your last column is containing all values P. That's why this is a tautology. So this first formula is equivalent to second formula. So in this way, we can check equivalence for any formula. Have you understood what is the concept of equivalence?
Yes, ma'am.
Okay.
Yes, ma'am.
Good. Now here, an example is given. Show that P conditional, Q conditional R. This is equivalent to P conditional negation Q or R. This is equivalent to P and Q conditional R. So here we have to show equivalence between these three formulas. Now we will consider first formula as P conditional Q conditional R. Okay. So to solve this example, we have to apply the law for this conditional. So this Q conditional R, this is equivalent to negation Q or R. How it has come? Because we have seen one formula, P conditional Q. This is equivalent with negation P or Q. That is, take negation of first variable or second variable as it is. So here we have to convert this Q conditional R as negation of first variable, that is negation of Q, or symbol second variable as it is. So this is equivalent to negation Q or R. Okay. So here in this formula we have to replace this one P conditional negation Q or R. Here we have replaced this Q conditional R by its equivalent formula negation Q or R. So again we have to replace this conditional. So what we have to do? How to replace this conditional? Again using same formula. Take negation of first variable, that is negation of P, or second variable as it is. Now here this second variable is equivalent to this formula. So we have to keep that formula as it is. So P conditional negation Q or R, this is equivalent to negation P or negation Q or R. Okay. Now here there are two different terms. whose are containing negation. So we can put these both terms in single bracket. So negation P or negation Q, and outside of bracket we can place R. Okay. Again, negation is common between these two terms. So we can take that negation outside. So negation in bracket P and Q, because we have taken this negation outside. So this all becomes AND or R. Okay. Now check, whenever there is negation of first variable or second variable, then that is equivalent to P conditional Q. So here value for that P is P and Q, and for Q is R. So its value is P and Q conditional R. That is given as our third formula in equivalence. So here these three formulas are equivalent. Yes, have you understood?
Yes, ma'am.
Just we have to apply the laws, those we have seen, and that from that you can solve any example. Okay. Again, next example is given. Show that this is equivalent to R. That given formula is equivalent to R. So just look at this formula, you will come to know that AND R is common in each and every parenthesis. If you consider first parenthesis, AND R is there, second AND R is there, third AND R is there. So we can take that AND R outside the bracket. So take here we have taken that AND R outside the bracket. So what is remaining? Negation P and negation Q. So here Q and R or P and R. Again, if you take this and R outside this bracket, so what is remaining? Q or P, because we have taken this and R outside. Now, again, if you take here is and R, here is and R. So again, from these two, we can take and R outside. So what is remaining? We can put in one bracket as negation P and negation Q. This is the one bracket, or Q or P. This is in another bracket. Now we can take negation outside from first bracket. So negation of P or Q. This and becomes P because we have taken this negation outside, or P or Q and R. Now check, what is the value for negation of P or Q or P or Q? This is just like negation of P or P. So value for that statement is P, because if you consider value for P is P, then negation of P, it becomes F. Okay. So P or F value is always T. That's why value for this whole formula, it becomes T. So P and R. So final answer is R. So in this way, we can show that equivalence. Shall I repeat this example once again? Or have you understood?
मॅम तिथं टी कसं आलं ते सांगा परत.
इथे का? Okay. So here, up to this step, negation of P or Q or P or Q. This is one bracket, and outside of this bracket, negation of R is there. Okay. Now consider P or Q as P only. Okay. So negation of P or P. This is our formula. Replace this P or P by P. So negation of P or P. So what is the value for negation of P or P? T or F. What is the value for T or F?
टी.
T. That's why this value is T here. आपण फक्त अज्यूम केले की P और P हे रिप्लेस केले P ने फक्त. हा फॉर्म्युला काही पण असेल, जर आपण त्याला फक्त P नाव दिलं तर काय येणार? निगेशन ऑफ P और P. जर आपण p ची व्हॅल्यू t म्हटलं तर निगेशन ऑफ p ची व्हॅल्यू काय येणार f येणार आहे. सो t or f final value is t only. So p and r. Now p and r means what? The value of this formula will be depend on value of t. जर r ची व्हॅल्यू t असेल तर फायनल व्हॅल्यू t येणार. r ची व्हॅल्यू f असेल तर t and f काय येणार f येणार. Means what? That value is totally depend on r. That's why final answer is r. समजले का काय केलं?
Yes, ma'am.
Okay. Next example is given as show that this formula is tautology. कसं प्रूव्ह करणार आहे बघा. So here De Morgan's law is given. Negation of P and negation of Q. This is equivalent to, what we have to do? We have to take this negation outside. So if you take negation outside, this and becomes or. So negation of P and negation of Q. This is equivalent to negation of P or Q. This is the De Morgan's law. Again, here negation of P and negation of Q, this is equivalent to negation of P or R, because this and becomes or. Then we take this negation outside. Again, negation of P and negation Q, or negation of P and negation of R, that is this term. Again, we have to take negation from this both the brackets outside. So if you take negation from first bracket outside, negation of P or Q, this and becomes or. Or again we have to take negation from this bracket outside. So if you take that negation outside, negation of P or R. Okay. So again, from this whole bracket, that is from this both the terms, we can take negation outside. So negation of P or Q, again this or becomes and P or R. This is the simplified form of this term negation of P and negation Q, or negation P and negation R. So likewise, we have to also simplify this term negation of negation P and negation Q or negation R. So in the first step, we have to apply this negation inside. The negation कसा apply करणार आहे? Negation of negation P means what? This is equivalent to P only, because negation gets cancelled. Again, this negation we have to apply to and. So this and becomes or. Okay. Again, take the negation from these two terms common. So negation of Q and this or becomes and this negation will get cancelled. So final term is Q and R. So here P or Q and R. So again you have to apply the distributive law as P or Q. This is the one bracket and P or R. This is the another bracket. Now check what we have got for this whole term. We have written that one is equivalent to P or Q and P or R, and this last term is equivalent to negation of P or Q and P or R. So here we can say that if we consider this whole formula as P, okay, so P or negation P. Check here. For this formula, we have got this one is equivalent form, that P or Q and P or R, and for this last formula, we have got this is equivalent to negation of P or Q and P or R. So we can consider this whole formula as P. So we will get P or negation of P. check here. In this both the terms, only negation is different. So P or negation P is our simplified form, or what we can say. Here we have reduced the number of terms. So you will get P or negation P. So what is the answer for P or negation P? P or negation P. P or F?
P, ma'am.
P. Yes. That's why this given formula is a tautology. Have you understood? Just we have simplified this given formula, and from that we are getting that it is just like P or negation P. That's why its final answer is tautology. For this kind of problems, you need to solve more examples. Then only you will get how to solve the given example. And whenever they says show that, in that you have to solve that example without truth table, because whenever we have to show any equivalence or tautology or implication, then they have clearly mentioned in that question as solve this example without constructing truth table. So when they says without constructing truth table, you have to solve that example by using laws. And when they say show that these formulas are equivalence, but if they have not specified whether we have to use truth table or we have to apply the formulas, then all the time you have to choose the option as apply the formulas and solve the example without truth table. Because if your question is containing 4 marks and if you have solved that example using truth table, and if they have mentioned solve that example without truth table, then you will get only 1 or 2 marks, though your answer is correct, because they have mentioned that solve this example without truth table. So such questions are asked in university exam. So you have to focus on that example, what kind of question they have asked.
मॅडम फर्स्ट पी और क्यू ते कुठं गेलं?
This one, P or Q. This term म्हणते ना तुम्ही, P or Q?
हा मॅडम तेच.
आता इथे बघा, P or Q and दिले पुढचे टर्म आहेत. आता ह्या टर्मसाठी आपलं सिम्प्लिफिकेशन काय आलंय? And negation P and negation Q or negation R. त्या होल टर्म साठी आपण सिम्प्लिफाय काय केलं? P or Q and P or R. ओके, आता बघा P or Q and P or Q. त्याचं मीनिंग काय आहे? P and P. Its answer is P only. So likewise, P or Q and P or Q. Its answer is P or Q only. That's why this term is merged here. Repetition झालं तर ती टर्म आपण एकदाच घेणार आहे.
ओके मॅम.
Okay. So now we have to see the next point is duality law. So two formulas A and A star are said to be duals of each other if either one can be obtained from other by replacing and by and or by and. Or we can say that replace this conjunction by disjunction, disjunction by conjunction. The connectives and or are also called as duals of each other. If formula A contains special variables P or F, then A star, that is its dual, is obtained by replacing P by F and F by P. Then A and A star are called as duals of each other. So here I will summarize. If there are two different formulas, A and A star, then those two formulas are called as duals of each other if either one can be obtained from another by replacing and by or by F. This is the one condition. Second, if there are some special symbols like T or F, then we have to replace T by F and F by T. Okay. So here example is given. We have to write dual of this first formula, that is P or Q and R. So here what we have seen, we have to replace this or by and by or. So its dual is P and Q or R. Just replace and by or by and. Now check for the second example. It is P and Q or T. So replace this one as P, replace and by or. So P or Q, and replace this or by and whenever there is any special symbol like T, so replace this T by F. So final answer is P or Q and F. Okay. So can you tell me what will be the dual of formula C? Two conditions are there. When or is there, replace it by and. If and is there, replace it by or. And second, check for whether that formula is containing any special symbol like T or F. If T is there, replace T by F. If F is there, replace F by T. So apply the same rules and tell me what is the dual for formula C.
Negation of P and Q,
Hmm?
or P and negation Q or negation S.
Yes, correct. Because here just there is no any special symbol, so we need not think about that. Just we have to replace here and by or by and. Correct. Hello? Hello?
Yes, ma'am.
Some network problem was there. That's why I got disconnected. Have you understood how this example is solved?
Yes,
Yes,
ma'am.
ma'am.
Yes.
So take this example, second example for homework, you have to solve. You have to show this second formula, P or Q,
Madam,
and
screen.
Ma'am, screen is not visible.
tell
Screen
me
is not visible.
no, one second. Now check.
Yes, ma'am. Visible.
Yes, ma'am.
Yes, ma'am. Yes.
So take this second example for homework. You have to show this first formula is equivalent to second one by using rules. Those we have seen till so far. So take down. While coming to the next lecture, you should solve this example. Give me presenting. Roll number one. If you are there, just you have to say present. Okay. Sequentially. Roll number one.
Yes, ma'am.
Roll number two. Roll number two. Three.
Yes, ma'am.
If you are there, if you are present, just type message as P. Roll number two. Roll number three. Four. Five. Six.
Yes, ma'am.
Seven. Eight. Nine.
Yes, ma'am.
Roll number eight.
Yes, ma'am.
Okay. Nine. 10. 11. 12.
Yes, ma'am.
11 and 12. Both are there?
Yes, ma'am.
Okay.
Yes, ma'am.
13. 14. 15. 16.
Yes, ma'am.
17. 17. 18.
Yes, ma'am.
19.
Yes,
20.
ma'am.
19.
Yes, ma'am.
Okay. 20. 21. 22.
Yes, ma'am.
23. 24.
Yes, ma'am.
25.
Yes, ma'am.
26.
Yes, madam.
27. 28.
Yes, ma'am.
29,
Yes, ma'am.
30, 31, 32,
Yes, ma'am.
33, 34, 35,
Present, ma'am.
okay, 35,
Yes, ma'am.
36, 37,
Present.
38,
Present, madam.
39,
Present, madam.
40,
Yes, ma'am.
41, 42,
Yes, ma'am.
43, 44, 45, 46,
Madam,
47,
45.
okay, 46, 47,
Yes, ma'am.
46 is there, 47, 48,
Yes, ma'am.
49,
Yes, ma'am.
50,
Yes, ma'am.
51,
Yes, ma'am.
52, 53, 54, 54, 55,
Present, ma'am.
56,
Yes, ma'am.
50, okay, 57, 58,
Present, ma'am.
59, who is present, 58 or 59,
58 present.
okay, 59, 60,
Present.
61, 62,
Present.
63, 64, 65, 66, 67,
And 66. Present, ma'am.
Ma'am,
Present, ma'am.
65.
67
okay,
present, ma'am.
okay,
65, ma'am.
yes, 65, 66 and 67 are present,
Yes, ma'am.
68,
Yes, ma'am.
Present, ma'am.
69, so I will put this presently on your book, check it once again, yes,
Ma'am, 61 is present.
61 is there, okay. So I will read the absent numbers 2, 3, 4, 5, 7, 9, 10.
Ma'am, 2 present.
Present. Okay. 3, 4, 5, 7, 9, 10, 13, 14, 15, 20, 21, 23, 27, 30, 31, 33, 36, 41, 43, 44, 46, 47, 52, 54, 57, 59, 63, 64, and 69. So these
Madam,
are the
59 present.
59 is present.
Ma'am, 46 is present, ma'am.
Okay. Any another correction? Okay. Now we will see the next and last point from today's session, that is tautological implications. So for any statement formula P conditional Q, the statement formula Q conditional P is called as converse. Negation of P, negation Q is called as inverse, and negation Q, conditional negation P is called its contrapositive. Okay, so if P conditional Q is a given formula, then Q conditional P is called as its converse. Negation P, conditional negation Q is called as its inverse. And negation Q, conditional negation P is called its contrapositive. So based on this, they have asked MCQs in university exam. So take note of this. P conditional Q, if that is the given formula, then Q conditional P is called as converse. Negation P, conditional negation Q is called as its inverse, and negation Q, conditional negation Q is called as its contrapositive. Okay. So again, P conditional Q, this is equivalent to negation Q, conditional negation P. So here what we have done, if you want to take negation of both the variables, then we have to reverse the order of variables. If you consider this first formula, P is the first variable and Q is the second variable. Now, if you want to take the negation, then that order gets reversed as negation of Q, conditional negation P. So here Q is the first variable and P is the second variable. Again, Q conditional P. If you want to apply the negation, this will be equivalent to negation of P, conditional negation Q. Again, order of these variables gets reversed. Now we have to see what is meaning of tautological implication. A statement A is said to be tautologically implies another statement B if and only if A conditional B is tautology. Okay. So what is meaning of this implies? A implies B. Means what? If A conditional B is tautology, then we can say that A implies B. And this is the symbol for implication. So this can be read as A implies B. So in the equivalence, we have seen that A and B, if these are two different So here we have to solve the examples based on implication. So
मैम आवाज येत नाहीये.
consider this formula P and Q. How to show this equivalence? So how to show this implication? Hello?
मॅम तुमचा आवाज कट होतोय.
What होतंय?
हा.
Implication ची definition समजली का? What is meaning of implication?
No, madam.
नाही मॅडम.
मॅडम आवाज
No, madam.
तुमचा मला ऐकूच नाही
आवाज-
आला काय.
Have you understood what is meaning of implication?
No, ma'am.
नो मॅम.
No, ma'am.
Yes, I will repeat it once again because of that connectivity problem. Some points are missed. So what is meaning of this implication? Suppose there are two different formulas A and B, and we have to show that A is logically implies to B. Okay. Then, if A conditional B is tautology, then you can say that A implies B. Okay. We have to just show conditional between these two formulas is a tautology. Then only we can say that A implies B. This is meaning of implication. Likewise, in equivalence, we had shown biconditional between two formulas. So, if A and B, these are the two formulas, then we can say that A is equivalent to B if and only if A biconditional B is tautology. Likewise, here, if A and B are two formulas, then we can say that A implies B if and only if A conditional B is a tautology. So for the equivalence, we have to take biconditional between both formulas, and for this implies or for implication, we have to take conditional between those two formulas. If that is tautology, then we can say that first formula logically implies second formula. Have you understood now? समजलं का काय करायचंय? फक्त कंडिशनल घ्यायचे त्या फॉर्म्युलामध्ये, आणि जर ते टोटोलॉजी असेल, then we can say that A is logically implies to B. Now here one example is given. Show the following implications. So here in this question, P and Q logically implies to P conditional Q. This is we have to show. So for that purpose, we have to construct a truth table like P, Q, P conditional Q, P and Q, P conditional Q, conditional P conditional Q. So here we have to take conditional between this first and second formula. If that is tautology, then we can say that P and Q logically implies P conditional Q. Now check here, this is tautology. That's why these two formulas logically implies to each other. Have you understood now?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
Okay, good. Now check for the second formula, and you have to tell me whether P logically implies to Q conditional P. So again, same procedure you have to follow. Draw the truth table for this formula. This formula is containing just two variables as P and Q. So there would be four possible combinations of truth values. Now check whether your last column containing all values true. If it is containing all values true, then we can say that P implies Q conditional P. And for that last column, you have to take conditional between P and Q conditional P. Can you solve?
Yes, sir. Yes.
Okay. Take 2 minutes and solve this example.
Ma'am, tautology.
All are true. So here, this is equivalent to negation P conditional Q. So to show this equivalence, two methods are there. First one, in the first method, we can construct a truth table, and from this truth table, we can give the numbers to each and every column as 1, 2, 3, 4, 5, 6, 7. So 7 columns are here. So from this truth table, now check for this first formula, that is P conditional Q conditional P, column number 4 is there, and for this second formula, column number 7 is there. Now check the truth values. For this column number 4 and 7, both are having same truth values. That's why we can say that this first formula is equivalent to second one. This is method number 1. Now, in method number 2, we have to take biconditional between two formulas. That is biconditional between P conditional Q conditional P and negation P conditional Q. If biconditional between these two formulas is tautology, then we can say that these two formulas are equivalent. So whichever method is easy for you, you can refer it. Okay. This is for equivalence. Now here, the second example we have to solve. So prove the equivalence between P conditional Q or R, and second one P conditional Q or P conditional R. Now solve this example and tell me whether these two formulas are equivalent. If yes, tell me what are the values in the columns. What is the value for P conditional Q or R, and what is the truth value for P conditional Q or P conditional R? This is the last example for today's session. You can refer either method. You can give the column number, and from those you can compare those two columns, required column. If those are containing same truth values, then you can say that both the formulas are equivalent. Or you can use the second method. You have to take biconditional between these two formulas. If biconditional is tautology, then you can say that these two formulas are equivalent. Choose any method and tell me whether these are equivalent.
Yes, ma'am. Both are same.
Both are same. Okay. And those values are T, 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 F.
Yes. T, 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 T.
Okay. So these columns, that is column number 5 and column number 8, are having same values. That's why these two formulas are equivalent. Good. Okay. So then some questions are there, but we will solve those questions in the next session. So here, read this question just. Show the following implications without constructing truth table. So these kind of questions are asked in university exam for 4 marks. And here they have clearly mentioned without constructing truth table. So here you have to apply the laws. Based on those laws, you have to solve the example. Okay. So we will see these examples next lecture. So just let me know, have you understood today's concepts?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, good. If you have any difficulty, if you are not getting any point, then just remind me at that time only. Okay. So I will repeat it once again. Whether DMS is difficult?
Send करा.
हाँ सेंड करना है आजच करते. Okay. What do you feel? DMS is difficult or easy?
Easy.
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 Okay, good. Right. So we will stop here. We will see the next remaining point next lecture. Thank you.
Okay, ma'am.
Okay.